Well, welcome everybody back to tonight's webinar on Intro to VCarve. Tonight's part 2. We're going to be talking about Toolpath tonight. For those of you who were with us last week, we went over an intro covering kind of the navigation of VCarve, and that video is available out at the Next Wave website. I'll send out a link to it also if you weren't in that class last week. Tonight, we're going to be focusing primarily on looking at router bits and tool setup. It's a big topic, and there'll be quite a bit of stuff we'll be going over tonight. Next week, we'll be looking at some more design techniques, dealing with text tools and something called node editing and some vector editing. And then on the fourth class, we'll be working with 3D models, give you some highlights on how to make the most out of VCarve with 3D models. But as I mentioned, tonight will be on router bits and toolpath setup. It's a pretty technical topic. It's also one where a lot of questions come up. This isn't an area that requires a lot of creativity. It's really dealing with understanding the different kinds of bits and then the numbers that you use for feeds, speeds, depth of cut. A lot of new terminology here that you need to program, and then you program that into your VCarve program. So next week, we'll get into some more creative stuff. But tonight, like I said, with the router bits, it's a pretty heavy technical stuff. So bear with me. Near the midpoint here tonight, I do have a summary sheet that I'll be showing you that you'll also get a copy of. It's kind of a cheat sheet because there's so many different variables involved with setting up router bits and toolpaths. And I've kind of boiled it down. For those of you that have a Shark desktop tool or another type of desktop tool, then the numbers that I have will definitely apply to you. If you have or use a larger industrial tool, then I'll mention something about that as well. But the numbers tonight are specifically for those who have a Shark or similar benchtop tool. Last week, we talked about the different areas in the VCarve program, and we talked about the right side, which is the toolpath tools, and we talked about how that area breaks down into 4 separate areas. This middle area right here with the toolpath tools are the one we're going to spend most of the time with tonight. But one of the questions that come up is what's the difference between VCarve Pro and desktop? And on the left side there, I've highlighted the tools that are in VCarve Pro that are not in desktop. And I'll give you a quick description of these. There's a lot more information on these out at the VCarve website or the Vectric website. And if we have extra time tonight or next week, I can go into some of the details also. But first off, right up here, that's called a VCarve inlay program. And that's for doing kind of a 2-part puzzle fit using the VCarve router bit that puts pieces together. You may have seen work that's done with that. It's a great technique for doing inlays, and that's a specific toolpath that they have created. Now, that just showed up in version 12, and you do not need that to actually do VCarve inlay. There is a way to use the standard VCarve toolpath to also do it. So if you want to do that without VCarve, there's techniques out there available to do that. If you have an interest in that, drop me an email. I also have some information on that also. But the new tool is quite handy if you do have VCarve Pro. Down at the bottom here, this long list here in the middle primarily deal with toolpath templating. And what that means, if you create a toolpath and then you want to duplicate it and use it with another project, you're able to save that toolpath with all of its specs into a file and then bring it back into another VCarve program. I've used it. It's pretty handy, but it's mostly if you're really doing production work or creating a lot of different kinds of VCarve files that you want to save the same toolpaths in. It's handy for that, but it is not a requirement for the average small hobby shop type setup. There's a couple of workarounds that we'll talk about how you can substitute in desktop rather than needing that. The other 2 ones at the bottom here, the one with the little pink corners, that's question, Wally?
No.
Okay, I'm going to go ahead and mute you. I just heard a little background noise there. And So what I was saying is that there was a little pink corner right here. This is called a it's a setting which will prevent the tool from running in certain areas of your program, so that if you have a clamp, you can block out that area with a rectangle, a vector rectangle, select that, and then when you run your toolpath, your tool bed will actually run around that area and avoid running into it. Again, it's pretty handy, but with some careful layout, you don't necessarily need that either. And then this last one over here is called job setup summary. And basically what that shows you is that shows you that it gives you a printout of the different settings that you have in your VCarve file, so that it'll give you a list of your toolpaths, it'll give you a little picture of your drawing. It's kind of a handy little summary for a job summary. Again, not a high requirement, but it is handy. But there are a couple of things that VCarve Pro has that VCarve Desktop doesn't, but on the toolpath side, those are the main differences. So as I mentioned tonight, I want to talk a bit about the toolpaths, and then we're going to spend a lot of time in the tool database looking at what it takes to set up a tool bit for a small desktop machine. The toolpath operations here highlighted in red, I'm going to talk about those tonight specifically. Those are also some of the most commonly used ones. Probably by far the most commonly used ones are these three right up here, the Pocket Profile and VCarve. And then if you do a lot of 3D carving, those two are highly used as well. Some people definitely make use of the drilling. Some of these others are all specialties. And so it's for special type of applications. But tonight we're going to take a deeper dive into all of these and then look at the tool database setup for what it takes to set up a basic tool bit. I mentioned last week how the tool paths, you can think of them kind of like a tool in your shop. So the profile tool path acts a little like a table saw or a bandsaw or a router table. And you could use that with almost any kind of bit, because what you're doing is simply following a line. And then you can set that bit up to cut part of the way through your material, all the way through your material. Or with a profile bit, you can set it up to do the side of your material or something down the middle. So if you think of this as you're following a line and you're either going on the line or inside or outside the line, it's pretty straightforward in its concept, and it's probably one of the big workhorse tool paths of CNC work. The next one is a pocket tool path, and it's obvious from the pictures here that it's for pocketing out or routing out an area. And again, you can set it for a certain depth, multiple depths. You can go through it all the way through the work also. That's not as common. Most often it is used with a straight bit, but if you're using it to cut out bowls or trays, you can also use something called a radius end mill, which is in the right side there, which has a flat bottom. Sometimes these are referred to as bowl bits. And you can see the pattern there where it leaves a nice radius on the inside. So that's pretty handy also. But that's your pocket tool path for doing mortise type cutouts. And then the third one that is really common is the VCarve tool path. What's really nice about this is you can very quickly carve lettering or designs with a V-bit to get very decorative shapes as a result. And the three designs you have here kind of sum up. If you understand how these are created, then you have a lot of control over what you can do with your V-carving bit. Now, the one on the left is a full depth V-carving. So you've got the letter V. In your drawing, there would be a vector that goes all the way around that V, and you would then carve that out with the V at what's called a full depth. This one has a flat depth, the one in the middle, using the same shape, the V, but either the tip of the router bit, the V bit, flattens this out, or you could use a straight bit if the shape is large enough to go in there and clear out the flat area also. Now, this last option, I call this a reverse V carving. You're still using the same V shape, but we've added a vector square around the outside of it. And when you have two vector lines like that, then the V carving toolpath goes between those. Rather than on the V, it jumps to the outside of the V. And then it'll carve in this area. So these are the basic three types of designs or techniques that you use with V carving. And from here, you can create a wide variety of designs and shapes. It really is one of my favorite toolpaths because the carving goes fairly quickly and the results are really decorative. And it just doesn't do it on lettering, you do it all kinds of shapes. One of the other toolpaths that I personally enjoy a lot is called the texturing toolpath. Takes a little bit of practice because there's a lot of settings in there. But in this case, you can see depending on the diameter of your ball nose bit or your core box bit, you'll get different results. And for this particular setup, I did V carving for the T in the middle, and then the texturing obviously goes around the outside. And then there's a little trick where you can add a little bit of an offset so the texturing doesn't touch either the edge of your project or touch the lettering. So you get this nice little tiny flat area all the way around, which is quite handy. In this side over here, I've used a larger ball nose bit. And this one, if you look closely, you can see I didn't have the offset quite wide enough. And you can see how right here at the bottom of the T, how it gouged the bottom of the T. It gouged a little here at the top. So in this one, I really needed a little larger offset to give me a little more area around there. But it's a fun one to play with. You can control the depth of the cut, the length of the cut, the overlap of the cut, the randomness of it. So there's a lot of different settings you can control. And surprisingly, you don't have to cut very deep. So like the 1/4 inch bit, this looks fairly deep, but it's probably no more than 1/10 of an inch. And lots of times I'll only cut about 50 thousandths or about 1/16 of an inch deep, and I still get a nice texture with it. The other one I want to point out is the drilling toolpath, because this is one that a lot of people ask about. And the drilling toolpath is like I said, think of it as your drill press, right? But its action, it actually isn't moving the tool rod. It's going over to a circle or a hole and drilling down through the middle of that. And so whether you're doing like multiple drilled holes or even something like a cribbage board, it's handy for that. You can use a router bit like I have shown here, and that will work to drill the holes, but also you can buy a collet. Collets come in infinite sizes. So if you have a drill bit, say a odd size drill bit or an 1/8 inch drill bit, you could get an 1/8 inch collet and you could put a drill bit in your router, slowing the RPMs down, slowing the feed rate or slowing the plunge rates. Anyway, the drill toolpath has some options, just like in your drill press where it's called pecking, where you drill a little, pull it up, drill a little, pull it up, so it clears out the chips. And when you do that, you can cut some very small holes and many of them very quickly. Anything over a 1/4 inch diameter hole, or even much over 3/16, I will usually use a router bit for, but if I get under that, I'll actually switch out to a drill bit to drill those holes. Now, I want to take a little deeper dive into the toolpath windows, and I say there are 3 main windows, and the way that works out is the first main toolpath window to think about is what I call the toolpath types, or the toolpath operations over on the right. And that's, again, where you select your particular toolpath. Now, when you click on one of those tools, it will then open the toolpath settings window where you can edit the settings and modify them for that particular toolpath. Now, that toolpath you've just opened up here, of course, will be associated with some vectors in your drawing. And then these settings will be associated with that particular part of your drawing. Within the toolpath settings window, there's a little select button. And when you click on that, that's where you actually select the specific router bit or router bits, plural, that you want to include in this toolpath setting. And that opens up your tool database. And your tool database is a collection of router bits. And we're going to take a much closer look at that coming up. But those are the three windows that you primarily work with. And the two on the left are the ones where most of the work goes on when you select a toolpath type on the right. And then you open up the toolpath setting window where you edit the settings for how that bit is going to operate. And then in the one on the left, the database is where you select the specific bit and you have settings related to that bit. So as I mentioned, there's a lot going on here. And tonight we're going to spend the first part of the meeting talking about the left side, the Toolpath database, and then I'll actually open up vCarve and we'll take a look at the middle section there of the Toolpath settings, and I'll give you a live demonstration on how those settings are set up and the effect that they have. So next up, I want to talk about setting up a basic end mill. And we're going to look at a lot of the settings involved in a basic end mill. So as I mentioned earlier, a profile toolpath typically uses an end mill, although you can use other bits, but that's a pretty common one for doing cutouts. If we were to cut this star out, we would use the profile toolpath. So when you select it, that editing or that setup window pops up on the right side. This is that toolpath settings window I showed you earlier. And within that, there are several settings that you're going to use when you set up the cut out that star or whatever vector you're working with. But to start with, of course, you need to select your router bit. So in this case, you're going to hit select. That'll open up the tool database. And within the tool database, on the left side, is your tool library of router bits. And then on the right side are the settings specific to that particular router bit. Now I'm going to run you down. We're going to spend a lot of time right now talking about this right side that has the red box around it with all these settings. When we get into the live software, I'll actually show you live how to set up a new router bit so you can create a collection of router bits specific to the ones you have in your shop. But for now, I want to talk about the settings here. So you select the bit, you click on it. When you click on it, the information for that particular bit as it currently exists inside your database then pops up on the right side. First, you have the name of the tool at the top. And then down one layer, you have the tool type highlighted there. And there's a little note section in between, that little white space. And you could enter any kind of notes. If you want to put the brand of the tool, when you bought it, you know, what kind of projects you used it on, any special notes you want to put in there, you could put in there. The name of the tool up here can also be edited. That's a little bit of an intermediate or advanced feature, so you can definitely do it, so don't be afraid of it. You just click on it. But some of these settings also have formulas attached with which are automatic. And once you click in there and start clicking around, you'll see some of that information. But to start with, it's probably just advisable just to use the default name, and any special information you want to add to that bit, you could put in the white area. Next in line is the geometry. And if you're dealing with inch tools, then you'll select the units for inch, of course, and then the diameter of the bit. That's what that represents in the case of an end mill. And you can see that highlighted on the right side of the screen there. That's actually part of the program. And we all know what diameter means, but for the case of an end mill, it's the diameter of the tip. Next in line is the number of flutes. And two flute and single flute are the most common bits and probably the recommended number of flutes to use on a small CNC. There are 3 flute bits on the market and even 4 flute. I've used those, but frankly, more flutes are not better. Fewer flutes are usually better with a desktop. And we'll get into some of the calculations later, but generally, 1 or 2 flute bit is what you should be using. It's not that you can't use the 3 flute, but what happens with the 3 and 4 flute, you have more flute in contact with your wood, and it has to do with something we're going to talk about a little bit later, which is called chip load. But it actually, a 3 or 4 flute bit heats up a lot more than a 1 or 2 flute bit, and it creates a lot more dust and less chips. So it actually creates hotter cutting. The bit gets hotter, it tends to wear out sooner. You can burn your work easier with a 3 or 4 flute bit. So I usually recommend people, especially with these smaller tools that don't travel super fast to go with a 1 or 2 flute bit. I use both, and for a lot of work, I prefer this bit right here to the right is kind of one of my workhorse bits. And then for some cutting, I have that one. And then I have this large 2 flute one for some larger cutouts. So yeah, all 4 of those I have these in my inventory, depending on the diameter and what I'm cutting. And we'll talk more about that later as well. Next in line, we have pass depth. And pass depth is like a layer cake. How much are you going to cut off with each pass of the tool? And so in this case, it's set up to pass depth of 1/8 of an inch. And you can see how that then cuts down in multiple layers. There's also a place within the Toolpath editing window where you can modify this and override the default settings. So in the tool database, when you set up a bit, it's probably good to just go in there and set up a default setting. And then later you can modify it either in the database or in the Toolpath editing window. When we go to the live software, I'll show you how to do that. Next in line is the step over. And you can think of step over like when you're mowing your lawn and you're stepping your lawnmower over by a certain percentage. In this case, 40% is the default amount for a end mill bit. Part of the theory behind that is that when it's cutting like it is right now, it's always cutting on the leading edge. And there's only one, if you have a 2 flute bit, there's only 1 flute engaged with the material at a time. Now, if you're cutting a groove, then obviously it's going to be both sides of the bit, and that's just the way it is. It's not a perfect world with some of these. There are some compromises, but the good news is if you kind of stay in the general zone of recommended settings, things work out well. Sometimes you're going to create a little more dust. Sometimes you're going to create a little more, maybe a big chip, and your machine may be working a little harder than normal. But if you're kind of in the middle zone, it's surprising how well it actually works out. Now, the one exception to this 40% step over, you may be wanting simply to put if you got a really large diameter bit, like a 1 or 1.5 inch bit, you may not want to go 40%. You may just want to go 20%, just like with your lawnmower. If you're cutting really heavy grass or wet grass, you're not going to move your lawnmower over as far, and that's totally acceptable with CNC also. The other situation is if you're surfacing a spoil board, then you're typically just taking a light pass. And that's like if you're taking such a light pass that you could actually, and you maybe have a 1 inch or 1.5 inch router bit end mill or similar flat cutting bit. In those cases, you could actually step over upwards of 80%. So you get the job done a lot quicker. Again, very comparable to mowing your lawn. Next up, we have this area, probably one of the big mysteries for a lot of people starting out, and it certainly was for me when I started out many years ago, on this feeds and speeds. And we're going to spend some time talking about each one of these settings so you understand what they do and how they work together. So the first one is spindle speed, and that's the RPMs of your router bit. Now, if you have an automatic if you have a spindle with the VFD, and if you have, for those of you who have Shark, if you have an automatic interface cable where it will set the speed automatically, then you actually set the speed in VCarve, and what you see here, the 18 thousandths or 20 thousandths or 22,000, wherever we set it at, that will be saved out in your G-code file, and then that will automatically change the speed of your spindle for this tool path. Now, if I have another tool path that I use a different spindle speed, when the router gets to that tool path or the program gets to that tool path, it'll change it to that speed. So it's very convenient having that setting in here. If you're using a woodworking router or you have one of the SD smaller tools that uses a little trim router, then you have to set your speed manually at the woodworking router. Or if you have one of the older Shark machines before they had the automatic spindle control, there are some spindles out there that don't have automatic control on them, and those you also have to set manually at what's called the VFD controller. If any of you have any questions about that relative to your particular machine, again, you can ask me along, tonight or drop me an email. I'm glad to help you out with that if you need further understanding of that. Now, the spindles that come with Next Wave machines are rated up to 24,000 RPMs and as low as possibly 8,000. Practically speaking, whether it's the 2-horse or the 3-horse, I most of the time run those between 16 and 22,000. I rarely, if ever, run them at full RPM. Part of it, at the high RPMs, I'm mostly creating sawdust. It's putting extra wear on the router bit. It's putting extra wear on the spindle, and I just get better performance at a slower RPMs. So for small bits, small diameter bits, V-cutting bits, I'll run 20 to 22,000. And then for straight bits, I'll run maybe 18 to 20,000. And I've occasionally dropped it down as low as 16,000. Industrial machines, surprisingly, or mid-size, say, cabinet shop machines, they'll often run theirs as low as 12 or 14,000, but they're also dealing with a 4, 5, 6, 7-horse spindle. So that spindle has a lot of torque to drive that bit through the wood. So on these smaller benchtop tools, you have to run them slightly higher than what might be recommended by the bit manufacturer in order to maintain that inertia of the bit going around. And we're going to go take a closer look at this. Also, I have a table with some specific numbers in it. The feed rate is the forward movement. Inches per minute is typically what that's set at. And much like miles per hour, inches per minute is the one that we use for a sharp tool. Other tools use inches per second. Do make sure that if you're using a sharp tool, you have it set at inches per minute, because if this is set wrong in VCarve, it'll output the wrong file, and you may find your machine either running super slow or super fast because the conversion isn't always, it doesn't always synchronize when you bring it into the machine. So that's that setting. We're going to talk about some specifics on that as well. Next in line is called the plunge rate, and the plunge rate is like a drill press. So think of how fast it drives it into the material. And so somewhere between 50 and 100% of the feed rate is what I run this as. And I'll show you those numbers in a little bit too. But again, think of it practically speaking, just like in a drill press, you're not going to want to ram that drill bit down into your wood super fast, nor are you want to go down super slow, because it'll burn it and it's a waste of time. Now, all these numbers work together, or several of them work together, to create kind of the magic number, which is called chip load. And chip load that you see highlighted there in the lower right, that's not a number that you can enter. That's a calculator there that's been added by Vectric. That didn't used to be in Vectric. They added this a version back, and it gives you a chip load for a end mill bit. Chip loads, from a math standpoint, and you see the math there, chip loads can only accurately be calculated on straight bits. So the chip load you see there when you run this with VCarve or a ball nose, it's close, but it's not. You sometimes have to take some other things into consideration, because the tip speed on a V-bit changes with the diameter. So some of those RPMs and feet per minute, some of that stuff changes. But for an end mill, it does apply. And a chip load is literally the thickness of the chip that, from a mass standpoint, is coming off the wood. Now, there's other things that affect it, but using it as a kind of a guiding point to work with is a really good way to kind of hone your tool to get the best performance. And there's a couple of reasons why chip load matter. It prevents overheating and which reduces the wear in your rotor bit. It can improve your edge quality and decrease cutting time. I've worked with people who sometimes run their machines at like 50 inches a minute. And frankly, it's unless you have an SD tool, on the HD tool, that's simply slower than you need in most cases for general cutting. I run my HD tool with a 3-horse spindle on it. And when I had the 2-horse also, always in the neighborhood of 80 to 150 inches a minute. And sometimes I go all the way up to the max of 200 with some cutting. If I'm cutting little parts or little holes, then I'll slow it down because otherwise it starts to act a little like a sewing machine and it gets real jerky. So I just slow it down. Think about driving your car. You can drive around a big racetrack really fast, but you're going around a cul-de-sac, you simply can't go so fast. And it's the same kind of principle here. So the smaller the area you're cutting, typically you're going to slow your feed rate down a little bit. But one of the most prevalent things you'll see up here that I'm highlighted here is the preventing overheating. Router bits, if you're using carbide tip router bits, the carbide is a crystal structure that's held in place with a bonding agent. Think of it like a glue that holds the crystal together, the carbide crystals together. And carbide itself is highly heat resistant, but the bonding agent has some limits. So if you overheat the bit, what actually happens is the bonding agent starts to break down and those little carbide crystals start to break off or fall off of the edge of the tool. At first, it's hardly perceivable and you really can't see it. But overheating a bit is a sure way to dull your bit prematurely. So you get the best mileage and the best tool life if you keep your bit, prevent your bit from overheating. And the best way to do that is maintain a good chip load, because by maintaining a chip load, every time that bit bites the wood, it's like going into cool material. So it helps to cool the bit. The heat actually goes into the chips. When you run some tests sometime, you're getting a good chip load. And if you can safely grab some of those chips, feel them, they'll actually be hot or warm because that means the heat is coming off. And when you stop your router bit, the big guys who run the big machines, they actually say you should be able to touch the router bit after it stops rotating, and it will not be too hot to touch. Now, that's not always the case with the benchtop tools because we generally are running a little faster than normal on these, but I'm going to show you a couple pictures later on that'll give you a clue of how good a chip load you really can get off of these tools. Now, the next slide I'm going to show you is packed full of information. And I always debate whether to show you a little bit at a time, but I'm going to show you this whole slide with all this information on it. We'll talk over all the specs one by one. So these are my suggested settings as a starting point when you're starting out to think about. So let's start out here, and I'm going to walk you down through all these, and then I would like to open this up for questions so you can ask some questions about this. But starting with flutes, as I mentioned earlier, 1 or 2 flutes are most common. The advantage of using a single flute in some situations is you actually double the thickness of your chip, because rather than 2 flutes cutting it in the same amount of time, 1 flute is cutting it, so it takes a bigger bite. And this is particularly useful if you're using a woodworking router or if you have an SD tool with a trim router, which tend to run always over 20,000, 25,000 RPMs. It's hard to get those RPMs down low enough on a woodworking router to get a good chip load. And that's where, if you can run a 1 flute bit, it's really handy. I know you can't always, but there are some great single flute bits out there for like quarter-inch router bits. The spindle speed, there you see the numbers I gave you, 16 to 24,000. Like I said, I typically run mine between 16 and 22, rarely topping it out. If you are using a router, somewhere between 70 and 90% of the router speed, because the routers tend to run at such a higher RPM, it's better to run those a little bit lower. Again, it puts less wear and tear in the router. It's not as noisy, and you're going to get a better chip load. If you have one of the trim routers on your on like your SD tool, those, 80, 90%, if you run, the problem with the woodworking router, if you gear the RPMs down low enough to get a really good chip load, you've also cut the horsepower. So a 2-horsepower router, 50% power rating, you're going to get 1 horsepower. So you've lost a lot of horsepower, a lot of torque for cutting. So you have to run those a little bit faster. Chip load, here's the target you're looking for shark tools and most benchtop tools, somewhere around 0.002 to 0.01. And you can see right now, this one says 0.0022. So I'm just a little over the minimum on that one. There are some settings, sometimes you may find it even drops down to 0.01, but you're not doing much of a chip load. So it's better to try and the easiest way is to swap out to a single flute bit or decrease your spindles, or rather increase your spindle speed. When you increase your spindle speed, you'll also, I take that back. When you increase your spindle speed, you'll actually decrease the chip load. So by slowing down the spindle speed, you take a bigger bite. Now this is where it gets complicated because feed rate also affects it. The faster you feed it, the bigger the chip load. The slower you feed it, the smaller the chip load. So the 3 numbers that affect chip load are the number of flutes, the spindle speed, and the feed rate. Those are the only 3 things that affect the thickness of the chip load. None of these other sections affect it. Everything else here that we set up here affects the load on the spindle or the load on the drive motors, but do not affect chip load. They can help chip load, but they don't change the number. And a good case in point is pass depth and step over. Talked about that earlier in a bit of detail, but if you, just like again, going back to the mowing your lawn example, if you don't take as big a bite or cut as deep with your lawnmower, it's a lot easier to mow. It'll take longer, but it's easier on your lawnmower. You don't clog it up. You can move along at a better pace. So when you prioritize this to try and get a good chip load, you're going to be working with feed rate, spindle speed, and number of flutes. It's always a bit of a compromise, and you have to kind of go back and forth. The good news is you generally have it's a pretty easy window, and it is forgiving. So this 0.002 to 0.001, when you start playing with the numbers in here, you'll find it's not too hard to hit some area inside there. But every so often, depending on your bit or the tool you have, you may be a little out of range on that. More often in your machine, you're going to be on the lower end of it. And that's just the way it is. Carbide bits are pretty tough. Unless they're actually turning black, they're probably not overheating too badly. On the feed rates, I've got this list here. You probably already peeked at that. But if you have an HD44, they're working on the maximum feed rate on that. But I think the last time I heard it was around 400 for maximum feed rate on that. The HD5s are around 200. And so that would be maximum. You could commonly cut between 100 and 150 very safely. And on the SD products or HD4s, around 50 to 100 is pretty common. Now, I mentioned for small shapes, and in this case, holes up to 1 inch diameter, if I'm routing those out, I'll typically reduce my feed rate to 20 to 50 for small shapes. But if I'm cutting out something like a sign or cutting out a cutting board or something like that, I'll maintain a much faster rate. I rarely run it on my HD tool. I only run this slower speed if I'm cutting holes or have a really zigzaggy design that has a lot of small areas to it. The plunge rate is set up. My recommendation here, it's a percentage of the feed rate, okay? This is a percentage of the feed rate. So in this case, I'm what, 80% of my feed rate or something. I rarely put my plunge rate much above 100 or 120 because, again, think of your drill press pressing down on that. It's going straight into the wood often, and you just want to ease it into it. There are a couple other tricks for making these things, making the cutting better. We'll get into that with the Toolpath. And next week, when we talk about some more actual cutting techniques. But this chart will give you a good foundation for getting started. You can obviously wander greater or less than some of these numbers once you gain some experience, but this is the safe zone for most of you. Also, a bit of a word of caution is you're going to get fee if you do go out to some of the router bit manufacturers, you'll be able to get their recommended chip loads, and that's what's highlighted here in green and red in the middle. However, the reason I highlighted them green and red is you can see the green numbers are within the range of my recommended settings for a sharp type tool or a benchtop tool. The red ones are pushing the limits or beyond. Most manufacturers, this chart is from Freud, but any industrial manufacturer, when they publish chip loads, those chip loads are typically for commercial application. They're not for benchtop hobby machines. So you have to take these chip loads with a bit of caution because it may be over ambitious for your particular tool. So I just point that out because I get that question often because the manufacturers are getting really good at providing tool databases that you could bring into vCarve. The problem is, though, is that the settings, the feeds and speeds are not set up for benchtop tools. They're set up for commercial tools usually. So you have to go back in and edit them also on your own anyway. And that's why later tonight, after we get through this information, I'm going to take you to a live demo and show you how to set up your own tool bits so that you can edit those and set those within the range that I'm recommending here. And when you gain some experience, then you can go back and adjust them as well and not just rely on the default settings from the manufacturer, which, like I said, are sometimes too aggressive. So here's kind of a summary of the tips. I've got a target chip load here. The chip load of 02 to 005 works great in most situations. Tips 3 and 4 talk about taking a shallower path depth or shallower step over. And as you see in the picture here, this is actually a 2-horse spindle cutting a block of walnut with a 1/2-inch diameter 2-flute straight bit. And even though I said a single flute is better for chip load, even with this 2-flute, I was able to get an excellent chip load. And you know that when you're getting shavings off the project. Now, you won't always get shavings that are this nice, but in some projects cutting solid wood, you should be able to get some nice shavings with many of your bits like this. The shavings may be tinier, but if all you're getting is truly sawdust, then you probably need to go back and reset some of your tool settings to increase your chip load. And here's another example. This is MDF. And I actually got curly shavings off of MDF. Now, this was done on an industrial machine. I have got little shavings off of my HD5 machine as well using MDF. But because MDF is made out of dust, you tend to get dust when you cut it. There's plenty of dust here in the picture too. But it is kind of surprising when you get your machine tuned in for much of your cutting and your chip load tuned in, you're not going to produce a lot of dust that goes floating around your shop. You're mostly going to get wood chips, maybe not this big, but you're going to get chips that aren't going to float around the shop. They're just going to either be easily vacuumed up or brushed up, which makes cleanup and using the machine a lot nicer. So again, we're in the live software now. We've got our Toolpath over here in the right. I'm going to walk you through similar to what I walked you through earlier. We're going to select the profile toolpath. In this case, I have it set up for a 1/2 inch cutting depth. Now the cutting depth is how deep this bit is going to cut. If you look at the little diagram over here, the C represents the cutting depth. The D is the start depth. Now it's a little misleading because typically the start depth is where the tip of the bit is going to contact the material or deeper. So you usually leave this at 0, which is the top of your material. But there are some applications where if you're cutting within a cutout that already exists and you want to cut a little deeper, you can set the start depth to cut down inside your pocket that already exists. But for most cutting, you're going to leave the start depth at 0, and then your cut depth is going to be related to how deep you want your profile path to cut. In this case, I am cutting it a 1/2 inch deep, and if we look way down here in the lower left, we see that material thickness is a 1/2 inch thick. So I'm using a 1/2 inch thick piece of material, which means I'm going to be cutting this through the material. Now, most people find it's handy to add a little bit extra to that, either 10 thousandths or even 20 thousandths. If you're running a spoil board on your table and you're not cutting right on top of your T-track, then adding a little extra guarantees that the bit goes all the way through the material. It's kind of annoying because the machines sometimes are so precise, or if the table's a little on a level, or your material is a little thicker in one area than the other, you could end up where you end up with a little bit of a paper joint at the bottom, a little bit of an onion skin, they call it, at the bottom. And it just can be annoying. So adding a little extra thickness there, depending on your setup, works out well. As I mentioned earlier, pretty much the next thing you're going to look at, well, actually, let's step down here before I go to the select. I've got this checkbox here called Show Advanced Toolpath Options. It currently is not checked, so this list is fairly short. Every so often, people will say, well, where are the rest of the settings? And by checking that, it expands all the other more intermediate and advanced settings. So I usually run mine all the way open, but it's not, for some basic work, it's not required, but it's handy. Okay, so next, we're going to select the bit. And from here, you can see here's my setup. I've got some my shop bits. I've got some various bits in there. There's a 1/4 inch bit. But what I want to show you at this point is most of you, when you get VCarve, you're going to see Imperial Tools and Metric Tools. And inside Imperial Tools, you're going to see a whole variety of bits. And you're certainly welcome to use those. You may need to modify the settings so they work with your machine. But what I want to show you tonight is how to set up your own library of router bits. So I'm going to back out of this, go back to my main menu, and this icon right here is a direct link to your tool database. And that opens up the tool database. So put that on hardwood. So I want to take a tour of this point to highlight some of the things I mentioned earlier. Over on the right side is your machine. And I currently have a selection of machines that I use. So I have variety set up. When you first set up your VCarve program, it will have asked you, and you probably went through a process to do that. If you haven't done that or are confused or struggling, again, please drop me an email. I can help you out, get your tool set up in that area. It's pretty straightforward. Also, VCarve, they have some excellent videos on their website also to show you how to get your tool set up. But you'll watch, you have your tool highlighted over here. So whatever tool you're working with that you own, you'll have that highlighted. The stuff here in the middle has to do with your tool database, saving it. I'm going to skip over that right now because that's a little bit of an advanced feature, and VCarve also covers that well on their website. What I really want to get to here is look at materials. You'll have a default set of materials. I've added a couple in here, but you'll have a default set of materials. So I'm going to start out with hardwood. and just take that. And if you're just starting out, it's okay just to leave this at hardwood or softwood. And for your first several projects, don't change it. And you'll hopefully understand as we go through this. Next, because you can edit this entirely, you could, if you wanted to, delete both of these. I typically don't. I leave them in there kind of as a reference, but I'm going to show you how to set up your own tool database within here. So your tool group. So I select this bottom one because I want my tool group to go below it. So I'm going to select the metric tools. I'm going to click on this option, which says add a group. So it added a new group right here. I'm going to give this group a name. I'm going to call it My Tools. And then I'm going to click apply, and notice how it renamed it. Then I'm going to go down and click on my add a group again, and notice how it added a group underneath it. Let's call this group end mills and apply. I'm going to go back and select my top level group, My Tools right there, and I'm going to add another group. And every so often this happens. Notice how if I expand my group, it didn't add it into My Tools. So you have to drag it up on top of there and drag it again, try it again there. There we go. It's a little fussy sometimes. You got to drag it around. I'm actually glad that happened. So I can show you how that works. And so here, I'm going to call this VBits and apply. And now if I wanted to change the order, I could drag this up there and back right up there, and I could put it above it. Doesn't really matter. Now I'm going to go select My Tools again, and I'm going to try to get another tool group under there. And this time it worked. And this time I'm going to make this one all those bits. And you can add as many groups as you want in there for the types of bits you have. Then within a given bit, let's start with end mills. You select the group, you go down and hit plus over here, which will add a tool. And notice how it added it. Now it defaults to bulldoze because if we drop this down, bulldoze is first in the list here. So let's click on end mill. And let's make this end mill 1/8 of an inch diameter. Let's call it a 2 flute. And I'm going to create some settings. So these are just some default settings. Pass depth usually comes up at about half the diameter of the bit. And that's a reasonable place to start. And then step over defaults to 40%. In this case, the spindle speed came up at 20 thousandths. That's fine. It's probably a setting I had earlier, so it defaulted back to that. Inches per minute, 150 and 100. I'm fine with all these settings for my tool, so I'm going to click apply. So now I have a router bit set up, an end mill set up. That end mill is also linked to hardwood, and I'll show you a little bit about that later. But let's go in here and get another end mill. And let's make this one a 1/4 inch bit. Let's make this a 2 flute also. Create the settings. And I typically go with about 1/10 of an inch on my 1/4 inch end mills. And then my step over, let's change that to the 40%. Speed looks good, feed rate looks good, we'll apply. Now, this is a 2 flute bit. If I want to add a single flute bit, I'll go in here. Well, actually, what I could do is I could take this bit and I could simply copy it. So now I have 2 identical bits, except this bit doesn't have any settings. But it's asking me, do I want to copy the settings from the one that looks similar to it? And I'm going to say yes. But I'm going to make a change in here, and I'm going to change this to a single flute. And I'm going to say apply. Now, before we leave this window, let's take a peek down here at the chip load. See what the chip load says, 0.0068. Notice when I go up to 2 flute, it drops to 3.4. So that's the effect that chip load or number of flutes has on chip load. I doubled my chip load by having my flute numbers. And spindle speed also has an effect. So let me tweak this down to 2,000, 20,000 rather. And you can see that also had an effect on the chip load. Feed rate also affects it. We'll put this down to 100. And now that increased or decreased it even further. So remember, I wanted this to be 0.02 to 0.002 to 0.1. So I'm in the range. I'll just save that for now and say okay. Oh, when I hit okay, it closed it. Let's just go back into it. Here's my tools. Here's my end mills. And I notice how I forgot to change the names on those. So let's go in and change the tool type to end mill. That's okay. We actually have to reset these up. So let's see, because I forgot to grab that at the beginning. So we're going to make that a 1/4 inch. And this was, we're going to make this the 2 flute. And quickly change these settings. I'm going to accept these defaults for now. And this one, you know what? It's a Baldos. I'm going to drag that up to the Baldos one. We can come back and use that later. But this one, I'm going to duplicate, make this a single flute, copy over the settings, and say okay. So that gets me back. So as you just saw there, I made a bit of an error with the naming, but I was able to correct it quite easily. And we're up here at Baldos now. So let me take a look at my Baldos bit at this point, since I already have one. 1/4 inch diameter. Those are typically, the 1/4 inch diameters are typically 2 flute. Pass depth, 0.05, that's fine. Now the step over, because I usually use my Baldos bits for 3D carving. We'll talk a lot about that in our last class. That's why I usually use a small step over, because I want that tip of the bit to do the carving and I'm not making grooves with it. So I'm going to apply and accept that. Again, here I can do the same thing I did before. I could duplicate that and I could copy that over and I can make this a 1/8 inch bit. And all the settings look good again. Save that out. And I hit okay again. I'll go back in there. So I've got my 1/8 inch. Let's take some V bits here. Let's add a V bit. Change the type to V bit. V bits are kind of unique, and I'm going to show you the settings when we get down here. 1/2 inch diameter, 90 degree. That's a pretty common size, so I'm going to stick with that. 2 flutes I'll put on this one. Actually, I'll put 1 flute because I use a 1 flute V bit. It does. I'll show it to you probably next week. It's a Mana brand insert bit. I love it. It does a really nice job. So let's create those. Pass depth, I do not, because when this bit cuts in, the depth, the width at the top of the cut is twice as wide as the depth of the cut. So I like to put that in half, and depending what I'm cutting, I might even take it shallower than that. But as a default, that's usually what I use. Now notice here we have 2 kinds of step overs. We have a final step over and a clearance step over. These default numbers of 2 and 20%, leave those alone. Those work great for every V-bit I have used on a benchtop tool. They work just fine. The clearance pass is, think of it as a roughing pass where it's going in, it's cutting out the majority of the material. And then the final step over is coming back at a very small 2% step over, and it's cleaning up the bottom and around the edges. So it does it in 2 separate types of passes. And so these numbers work well for that. So let's apply on that one. let's do a copy of that and put one more bit in there. And in this case, one of my other favorite bits is a 60-degree bit that's a 1/4 inch diameter. I use this bit for a lot of detail work. It's a solid carbide bit. It's made as an engraving bit, and it does a great job. Very sharp, single flute. And again, at the path depth here, I'm going to sneak that back a little bit or reduce that a little bit. Now it's giving me a 4 and 40%. That is also acceptable because that's part of the 60-degree default numbers. But I've also used the 2 and 20 on this, so that works as well. You'll notice the difference. In fact, I have actually used the 2 and 20, and I actually prefer it because it gives me a little finer cut at the end. So I'm going to change those back down to 2 and 20. Again, we've got the step or the spindle speed, the feed rates. These are fine for some smaller work. I could probably shake that up to about 100. And I've still got to, now the chip loads on V-carves are not as reliable as the chip load on the end mill, but it still provides a good starting point. So here you are. We've, in 10 minutes probably or less, set up a simple tool database with your own tools in it. And this is why you could add to your tools just the tools you have in your shop. Now, a couple more things I want to show you here is, remember how we had these two end mills, and one was a single flute and one was a double flute. So it's like, well, how do I know which one is which without opening it up? So if you open up, this is the 2 flute, and that's a single flute. Okay, if you open one of them up, if you go underneath, you can either add the note here, but then of course you have to open it up. But if you go inside this window here, there's some of the automatic programming that brings up the information on that bit. But at the end of that, I can type in 1 flute, and you see how it adds it to it. Now, you want to make sure to uncheck this box, otherwise it sets that as the default for all your bits, and you don't want that. So I'll click OK, and there I have 1 flute. I want to edit that a little bit, put a little space right there. Okay, so there I've got a 1 flute. I could go into this one, and I could call this a 2 flute. So you can modify those names as you like with a little added information at the end, if that's helpful. Same thing with your bulldozers. If you're using a bulldoze, let's say this bulldoze is set up. I'm going to set this one up for 3D carving, like that. And then I'm going to make a copy of this. Copy over the settings, go back into the name, but this one I'm going to use for texture. So the texturing toolpath, and for this one, I'm going to use the step over of say 40%, which will give you a larger step over if I use it for some kind of texturing or grooving or some other type of application. So you can vary, you can have now 2 different types of bulldozers set up depending on the use that you're using them for. So that's how you would do some of that for customizing the naming and such. The other thing you're going to run into in this window that might confuse you is the materials. So notice that when I select any of these bits, my V bits as well, I've got settings with all of those. But notice what happens if I go up and say, well, I want to cut some softwood. Notice how suddenly all these bits turned light gray, and I don't have any information. Well, the reason for that is, let's take this end mill single flute, bit right here is right now this end mill is associated with hardwood, and I want to use it in softwood. So I need to create settings for well, you don't have to always, but I'm showing you where this comes up because if you are, it gives you another way to set your settings. So I'm going to hit copy. And let's say in softwood, I wanted to go 200 inches a minute, but I wanted to go 18,000 RPMs. And I'm going to click apply on that and say, and leave it like, okay, so now what I have, notice how this one right here is now highlighted or it's bolder or darker. There, now you can see it better. That's because I have settings. So when I have softwood selected up here, bits that have settings that are associated with the softwood will be highlighted with information. Notice when I change it back to hardwood. They all turn dark and they all have settings. So this bit right here can be set up and have settings that are specific to any type of material that you have in the list above. If you want to add materials, you can click on here and even add your own material. You probably noticed I'm doing some testing right now with some leather cutting. And so I actually have some leather in here as some settings for my own, for some leather cutting. But like I said at the beginning, you don't necessarily have to set up separate router bits for separate materials. That's how you fine tune it after you gain some experience. If you stay within the general framework of the settings I showed you earlier, whether it's hardwood or softwood, it'll probably work pretty well for both of them, especially when you're just starting out. But like I said, if you wanted to set up a category, you could go in here and let's just put, I'm going to put general and click apply. So now I have kind of a general use category, and I could set everything under general use if I was just doing it as a default. So hopefully you find that helpful. I do get questions about this. Spend some time in there. The really good news is you can't really break it in the sense that if something doesn't look right, just change it. But do pay attention to your, when you do enter your settings, to make sure that these settings fall within the range that we talked about earlier. Okay, the next up, I'm going to go ahead and close out the database. Then I'm going to go back into my profile toolpath. And I'm going to select my tool. And, the default selection came up with this other group that I had. But I'm going to go into my new tool set here, and I'm going to grab my single flute. I'm going to grab it for hardwood. And I'm going to grab, those settings look good. I'm going to click apply and select. And so now that bit shows up here in the upper right. Now this edit window on the right side over here, you'll find this in almost all the Toolpath edit windows or setting windows. When I click on this is bringing up the settings just for this router bit, but these settings apply just to the toolpath you see here at the right. If I make changes in here, let's say if I got really aggressive and I took a 1/4 inch pass depth and said okay, you'll see I've got 4 passes right here. You'll notice that changes. I've got 2 passes. So my bit is now going to cut 2 passes at a 1/4 inch deep for the tool path that you see here on the right. But if I go back into my tool database and go to that default bit that I used, which was right here, notice that it still says 1/8 of an inch. So I have not changed anything in my tool database. That's why you want to think of your tool database as your default settings, your semi-permanent settings, your best practice settings, because you can always override them over here on the right side and it won't have any effect on it. So that was one way to change the pass depths, is by changing that. But if I go inside edit passes, this shows me those two settings. I can manually do it down here as well. But let's go back to the 4 steps I have, and let's go to 5. Click set. And now say okay. And now it says 5 up here. There's some other settings in here also that we can talk about maybe at a later time. They're a little bit more advanced, but this one right here is the one you'll probably use the most often unless you're doing some special setups. And just to show you how that affects it. So this setting again will override your tool database. It also overrides what you have inside the edit window. So they kind of work your way down here with priority. Next, we need to select a vector. So let's select that vector by clicking on it. And now we can go outside the line, inside the line, or on the line. I'm going to click outside the line. We'll come back and talk about some of these. Well, let's talk about this one right now. This do a separate last pass. If you look at the diagram here, it shows that the first passes are staying away from the material by the allowance amount. So if I want to stay away from the material, say 10 thousandths of an inch, which just leaves me a slight, it's like the thickness of 2 sheets of paper. Then on the last pass, it goes in and takes that whole area off. The reason for doing this is that if the edge of your product or your project needs a really smooth finish on it, doing this allowance, the separate last pass, you could go back. I refer to this like a jointing pass. It takes a small amount of material off in one pass the last time around. And I doubt that you'll ever go over 20 thousandths. And I find that in most cases, 10 thousandths is usually enough to give me a finished cut around the project. Because when you cut in layers without this set up, you are likely to get some step marks on the edge of the board from the router bit. That's just the way it works. If you get excessive step marking, it could mean that your tool is not trammed correctly, which means it's not perpendicular to your table, which is a different problem. But this is a way to get a nice smooth edge on your project. You can even do a reverse cut if you want to. Tabs. Again, this is what's going to hold this in place. Length of tab, thickness of tab, those are kind of the defaults I use. A 3D tab is like a speed bump. I prefer that as opposed to the brick tab, because on a brick tab, the router bit has to come to the edge, go straight up, go over, stop, and go straight down. It tends to leave more marks on the edge of the project, where with a 3D tab, like a speed bump, it keeps moving. It doesn't actually stop. It just slows down a little bit. Now to edit the tabs, let's say I want 4 tabs on this project. I can type in 4 and just quickly add tabs. Now, I may not like where they fell. So I could go over here, click on it, get rid of it. I could click here and add one, or I could click and hold and slide it. Add one here, click and hold, click and delete. Let's take this one over here, and let's get rid of that one. So it's very editable. And if you don't like what you have, then you hit delete tabs and go back again and do it again. So we now have those set up. The one recommendation I have here is ramping. Whenever you're using a straight bit, it's a good idea to ramp. A smooth ramp. Think of this like a boat ramp going into the water. It eases the router bit into the material. And, 2 to 10 times the diameter of the tool is what people recommend. On big machines, they'll cut through 3/4 inch plywood in one pass. So they got to go a long ramp. They might go 8-10 inches to get through that material. We're only cutting, about 1/10 of an inch deep. So I can set this at an inch is fine. I'll leave it at an inch for now. I've even done a little less than that, but that works out. Let's go back and select our project. And let's click. Oh, here I can name this. Let's call this cutout because I'm going to cut this project out. Now I get a warning that's telling me I'm going to cut through my material a little bit. That's my material thickness. My tool depth is set to 551. I know that. I'm okay with that. And now what else is it telling me? Okay, it says tool could not be created without violating keep out zones. Okay. I must have something else set up here as a keep out zone. So let's see what happens. Aha. So I had some default settings in here already with a keep out zone. That's what this purple area, and it's telling me that it's going to change that. So I actually have to go in my setting and manage my keep out zone. And I'm going to hit clear zones, close out of that. And it looks like I'm okay now. So let's go into the Toolpath preview window. If you didn't see how I got here, it's this little YouTube looking symbol for video. Let's reset our overall preview. Let's turn it a little bit. And there you can see our 5 toolpaths. And you can see the tab right there as well. Let's preview this. Let's go back and reset that. I'm going to click on this square here to make it visible. And I want to show you something. You see these light, get it around this way. Those light blue lines, that's the ramping. So what's happening is it's ramping down to the 4th pass. And then the 5th pass, it's ramping all the way from, remember how we have a last pass where it's taking the whole width of it? So it's starting at the very top, going to the bottom and taking the last pass all the way around. So open up the Toolpath again by clicking on it. Let's remove the last pass, calculate it. Notice now how the ramp just continues all the way to the bottom. Sometimes it's a little easier to see on a different shape. So let's take and put this on a circle. Open this up. Click on the toolpath to open it up. I can move everything over to this circle except for the tabs. So let's re-edit the tabs, add tabs, close, calculate. And here now, again, you can see a little better illustration of how that ramp, each one, and it continues to go a little bit at a time. We've got our tabs set up right there. And if we go over to our 2D view, we can see in our 2D view, you can see the direction of the router bit travel. You can even see a little spot here where the tab is allowed for. So there's information here in the 2D view that is useful. Now, the only reason I can see it in the 2D view and the 3D view is because I have this checkbox. This makes it visible. Okay, so that turns the visibility on and off. When the toolpath is highlighted, see how it's dark right there? That's called selected. So when I hit selected up here, it's referring to that toolpath only. When you have multiple toolpaths, you can only have one selected, but you can have multiples visible. But the other thing I want to show you that's really handy in the 3D or the 2D view is this tool right up here. It's called going from wireframe to solid view. Now watch when I click on this, how it turns it to purple. So it actually shows me where it is cutting. And even if I deselect the vector and so it turns black, I still see it and I can turn that off and on. This is particularly useful when we use some of the other settings in the profile toolpath. Let's say I want this circle to be slightly undersized because I want this to go inside, say, another cutout that I have, kind of like a puzzle piece. So I'm going to what's called offset allowance. I'm going to give this, say, a 2000, and I need to give it a negative because I want it to go a negative. It will move in the opposite direction of where it currently is. So it's on the outside. I want to move it towards the inside a little bit. So I give it a negative. Click OK. And let's zoom in here. Notice now how that toolpath moved in over that line. So now my circle is a little undersized by this amount. So think of this if you're fitting parts together, like puzzle pieces or joints or something like that. This is one way that you could affect that. However, if I wanted it slightly oversized, I could do the opposite. And now it's slightly oversized. It's a handy little setting that when you have the need for it, it's really very powerful. There are a few other settings in here, but for now, I think I'm going to leave it at that. We'll take a look at some of these others. I think I'm going to go back to this star shape and bring up a V-carving toolpath. Select the star. Again here, with the V-carving toolpath, typical starting depth is going to be 0, which means the top of the material. I'm not going to choose a flat depth on this one. I'm going to go in and get my router bit. Let's close up those. Let's get our router bit we created right here. Select that. And I'm going to start here and just accept all the default settings and calculate that out. It's warning me that I'm going to cut 1.5 inches deep. Well, that's really deep, and obviously my material is only 1/2 deep. So this is the kind of warning you should pay attention to. I'll show you why. If I say OK on that, so there's the star in the middle. I can turn off the visibility of the cutout, but watch what happens when I rotate this. Look at that toolpath. It's going right through the material. And if I preview that, it cuts right through the material. Probably something we want it to do. So I'm going to go back in there and I'm going to add a flat depth of 1/4 inch. Calculate it. Now we can see that it's staying inside the material. Now let's preview it. So see that roughing and see the smooth? That's the difference between the roughing pass and the finishing pass. I talked about that earlier, how the V-bit has 2 different settings. Let's take another look at that. That's the 20% step over where it's roughing it out. And then when that finishes, it'll then use the finishing step over of 2% to clean up the bottom. Now, it takes a long time because it's just the router bit, but here's the thing to watch. Watch how these corners are very rounded right now. And when this router bit gets out, it's going to go up in each of these corners. It's kind of the magic of V-carving. It's going to clean up each corner and give you a very sharp point. So there, see, it went up in the corner and cleaned that up nice and sharp. Now, for a star like this with all this flat area, you can see a little bit of texture in there. Vectric works really hard, has worked really hard to make this illustration show you what you're going to get on your board. So you likely will get a little texture from the tip of the router bit. It's worth paying a lot of attention to this preview because what you see is what you get. And I'm going to say 99.9% of the time. There's only been a couple of times in the last 15 years of using the software where there's been a little bit of an error here. So if you don't see what you like here, realize that there's either a problem with your vectors or there's a problem with your toolpath. it's unlikely a problem with the preview. It's either the drawing or the toolpath. The last thing I want to do here, because I mentioned about on that bottom, because we have this large area, we can use what's called a clearance toolpath. So we can add an extra bit. We're still in the V-carve toolpath. Go in and we'll select our 1/4 inch. Let's do our 2 flute, apply, select. And I'm just going to go ahead and hit calculate and watch what happens. Over on the right side, I now have a V-carve clearance toolpath and a V-carve toolpath. If we uncheck the last one, this is the part right here where the straight bit is going to cut. So we'll preview that. And you can see how that cuts. And the V bit only needs to go around the outside to clean up the outside. We do have a couple of spots right here where the straight bit wasn't able to reach. It's usually not too big a problem. Sometimes I'll go in if it really is an important carving, I'll go in with a chisel or something and just scrape that clean. So that's a basic setup. There's obviously more you can go with, but on the V-carving toolpath setup, those are the primary options. The other thing you can do is you also have, whether it's called offset, which in this case is kind of like a spiral, or raster, which goes back and forth. If we select that, you can see how the lines now are back and forth. The V-carve still goes around the outside edge, but the roughing one for the straight bit ends up being in a raster pattern.
I'm just curious, with the clearance bit, was the total time reduced?
Bill, I think I hear you, but you're breaking up a bit on your speaker.
I said, with the clearance bit, was the total time reduced?
Be hard, but I guarantee you how it will be hard. You don't want to be there for your initial part.
Sorry, Bill, you're still breaking up. If you want to type it into the chat, I'm glad to address your question. We do have a question in the chat about how do I know how many flutes the bit, how to count those? You simply look at the bit, like the picture I showed earlier, and it's how many cutting edges it has. That's what the number of flutes refers to, is how many cutting edges are on the bit. And like I said, most woodworking router bits are going to have 1 or 2 cutting edges. Some of the decorative cutting bits may have 3, and those still work okay, but most of them will have 1 or 2. Oh, good question. Yes, Bill, thank you. Was the time reduced? Absolutely. So let's take a look at this. So this little icon right here is the timing. If I look at this right now, and again, there's a couple settings here that matter. The rapid rate for Shark Tools is 200. Scale factor somewhere between 1 and 2. 1.5 is kind of a sweet spot to start at, probably. Notice what we have up here. It's going to take 5 minutes for the clearance tool and 49 seconds for the V-bit. So like 1 minute for the V-bit and 5 minutes. Scale factor is kind of a relative number because V-carve doesn't know how much time your machine pauses when it comes to a quarter, or when it, there's some governing in your tool that V-carve doesn't know about. So what I do is I run a test like this. I'll run it on the machine, and then if I say, well, let's see, it's actually taking, if I turn that down to 1, it's actually taking less time. So I turned that down to a scale factor 1 because it only took 3 minutes to run. Or maybe it took longer, so I put that at a 2 because maybe it took 6 minutes to run. So you have to play with the scale factor to do some testing. But let's take an example here. I'm going to take this toolpath right here. This little icon right here duplicates the toolpath. So watch what happens. I click that. I got doubles of everything. But let's take that one and put it up, pair these up like they should. So this is the first pair. This pair I'm going to open up. I'm going to remove that clearance path, and I'm going to call this VC2. Calculate that. Now let's go back and look at our timing. So look at that. If I just use a V-bit, it's taking 14 minutes. If I use a V-bit and a clearance path, it's doing 7 minutes. So yes, a straight bit, that's one of the reasons for it. It gives, not only saves a lot of time, it also gives you a smoother finish at the bottom. Any other questions from anybody?
Randy, when you're doing a pocket tool path, you typically try to run it with the grain?
Another good question. It depends on the setup, but yes, generally on okay, so there's sometimes you do a roughing pocket tool path and you do a finishing tool path. Roughing, I often will go across the grain, but on the finishing, I always like to go with the grain because if there's any router marks or scratches, it hides it with the grain and it's a lot easier to scrape it out or sand it out. Cross grain router marks, as we know, those are hard to sand out or scrape out. So yeah, I will usually orient it with the grain. Anybody else? Well, there's more than we could go into with this, but I'm gonna let this go and let this incubate with you guys. And if you come back next week or the week after, or you'll have my email, I'll send this video out to you. Again, don't hesitate to raise the questions. I'm very glad to help you out with this. This is a pretty technical topic, as you saw, but that's why I've tried to boil it down to these numbers. Still a lot to think about, but you should be in a pretty safe zone on your machine if you stay within this zone that I've showed you if you're starting out. And I wish you luck with that. And hopefully see you next week. Have a good night, everybody.
Night, Randy.
Good night.